Kia ora koutou, Reese from QuickSense here, and today we're looking at nonlinear graphs. Now, a nonlinear graph is just any graph that isn't a straight line, so it's not linear. We often see these in nature, and actually this question is a sort of a physics question, right? It's looking at a ball being thrown upwards from the ground. It goes up and then down, and over time you can see its path in terms of height. The question's asking for how many seconds until we see the ball reach a height of 10 meters on its way down. And that's really important because it actually hits 10 meters twice, right? We see it hit it there, and we see it hit it again there. Now looking at the graph, we can say it's between 3 and 4 seconds, but it's probably, right, 3.5 seconds. It's on the way down, right? So that's this part. On the way up, that's that part there. Now, in this next question, we are given a graph that is looking at the velocity over time and how that changes, and it's asking us about acceleration. Acceleration, one way we can see it, is by looking at the gradient of this graph. So if I take a point, for example, this point here, I can find its acceleration if I can find the tangent at that point, which has the same gradient. Okay. So with that in mind, right, we're wanting to know, well, when does it have the same gradient it has when it's at 3, which is just about there? Well, there's a couple of ways that we can do this, one of which is algebraically and using a little bit of differentiation. But we're given a graph, so we're going to solve this graphically. What does that look like? Well, I have some tangent here, but I'm going to use features of this graph to help me solve it. Right, so what are the three major features? Well, I have a turning point, and halfway between, a point of inflection. Now, because cubics, or certainly this cubic looks to be so, are symmetrical, I know, right, that this is going to have the same, or the graph will have the same gradient when it is in the reversed or the symmetrically similar position. Well, what do I mean by that? Well, I take this here, and I ask how far away from it is my point here. Well, it's 1 second away. So now I look at my other turning point, and I ask what's happening 1 second away from this? Well, we're at this point here. And looking at this, I can see that it's actually really similar, right? Because of symmetry, in this instance, the graph, well, this car will have the same value of acceleration at t equals 3. When is that? T equals 9.